Hello, this is Reverb Audio, and this is an episode about power conditioning. So a few weeks ago, 29 asked me whether I had any experience with the line conditioning, power conditioning, and John Sveda also shared a few excellent advice on the subject. And I haven't responded to him yet, but this video is part of my response to him and also to 29 about power conditioning. And this, what I'm showing to you, is not everything that I learned about power conditioning, and it's not everything that I'm using, but I'm showing this because this is where the history of power conditioning has started. You might be a little bit surprised because we are not looking at my audio system, but we are looking at my Blu-ray and the projector, which are mounted on the ceiling. And as you might have guessed, they have their separate power conditioner here, but it is not what the name suggests. It's only a Rotel box. I got this unit in a non-functioning condition and I completely gutted it and I built my line conditioner inside. So answering 29's question, yes, I have about 20 years of experience fooling around with power conditioners and finding out solutions, combinations, what work, what doesn't work, and there has been like tons of debates online, people saying, oh, is this a better power conditioner, is that a better power conditioner? Unfortunately, the situation is effing complex. So power conditioning is something that cannot be solved overnight. And the problem of that is that each unit is sensitive to different things. I mean, there are different kind of distortions and noise pollution in the power. Oops, my light just took a dive. Let me just get it up. Okay. So actually every unit is sensitive to things to a different degree. So for example, if you have a Blu-ray player and a projector, they will be happiest with a different kind of line conditioning than your turntable or your amplifier or your DAC or your computer. So going back here, I start with the power conditioning on my video because this is where the history of power conditioning started with Qualcomm filters, because in this unit I have Qualcomm filters. And let's have a look at that, what Qualcomm filter is. So now here at the computer screen, sorry it will be a bit shaky because I'm holding in the hand, you have to type these words. If you look at your favorite supplier, now Qualcomm filters, which is basically a common mode inductor. That's the center of these filter units. And let's see, this is how they look like. So if you see the box like this, that's how it looks like. This is at the heart of the, I would say, 95% of line conditioners. It's this unit. This is how it works. On one side there's 2 prongs, on the other side there's 3 prongs. So you connect the negative and the positive to these legs coming in, going out, plus you have also one terminal for the ground. Let's see, if we zoom in, then you can see the schematics of what it is about. So what you can see is there's on the input side there's a resistor between the two line in wires, so it's like the positive and your negative, and there's a resistor which is a high value resistor, there's a capacitor, and then there's a common mode choke, and there's another capacitor afterwards. And then the ground wire there, that tiny thing, it's connected with two capacitors to both legs. So if you just look at this looks very complex, but a simplified version where you don't need to use a common mode inductor based Corcon filter is something that John Sveda has shared with us. And let's draw it. So I'm using super high technology right now, marker and paper. So here we go. So what John was suggesting, that a quick and dirty and easy way of power conditioning is when you have your line in voltages. Let's say this is the neutral, this is the hot, and this is the ground. So in color code, this will be the white, at least in the United States. This will be the green, and this will be the black wire. So here and in between these, so what do we do? So he said to put a capacitor between here, between the neutral and ground, put another capacitor between here and there, and put a third capacitor between this and that, between the neutral and the hot. And each of these capacitors you can start around with a 0.68 nanofarad, or actually microfarad, sorry. So 68 nanofarad. So that's a good starting size, and eventually you can play around. So what the different Corcon filters differ from one another is that they use different size capacitors on these things, or they can use multiple capacitors, or sometimes they can use a resistor and a capacitor network, and they balance these values in such a way to filter out specific EMI, RFI noise from the lines. And by varying the actual capacitances, the resistance here, and of course in the Corcon filter, what is more than this, taking more, is that we add the common mode choke. So basically there's an inductor that disrupt the lines, so it's in series with the neutral, in series with the hot, and these two are on a common core. And the value of this inductor is around 1 millihenry. It can be lower than that, it can go down to 0.27, or it can be up to like 2 millihenry. But these are the values that you generally see in Corcon filters, and if you want to build your own, then just get a common mode choke that is between 1/4 to 2 millihenries, and play around with capacitors like up to 68 nanofarad. But you can go higher than that, you can use like 1 microfarad, even more, but then we will spill over to something different. That's not just EMI filtering, that's using capacitors to adjust the phase angle of the incoming power. That's a different subject for a different time. And basically there are these Corcon filters, and the difference is between those values they use, how they employ the capacitors, how many they use. They employ capacitors also after the common mode inductor, and sometimes they double it up. So you have one section of this and then another section of common mode inductor plus capacitors going after it. So basically 2 Corcon filters in one box. And then of course, if you look at the pricing of these filters, let's just go back here and let's look at the computer, at the price list. Okay, So as you see, when I did the search, it shows up as power line filter modules, Qualcomm filters, and these are all, I narrowed the search to one phase filters because you can get them in three-phase version as well. And you see the basically the other difference between using like different inductances. It sometimes your search engine might show up and you can search for the exact inductance. If you know that there's a specific frequency bothering you, this will not be common audiophiles. This is industry applications where someone has come and measured what's going on in that area, and then there's a specific instrument that needs specific filtering, and then you can build a specific filter for that, and then you can search. If you don't know that, then go for the current rating and pick the one that has the highest rating, because that will have the least negative effect on the power delivery. The smaller current rated version you get, the more it will choke up the dynamics. And as you have seen, I put this filter on my projector and on my Blu-ray, but I do not have this filter on any of my amplifiers or not even on the CD player. And yep, so amps do not get it, because if you use it on an amplifier, it really chokes out the dynamics and the life from an amp. It's, even though it's just like a tiny inductor, tiny common mode inductor with a very minimal resistance, but that is enough to severely take out the dynamics of your amplifier. And not just amp, but preamp as well is sensitive for that. Even my phonostage, if I put my Hagerman violin on a power conditioner that's Qualcomm based, it's going to decrease the dynamics noticeably. And my other news about the Qualcomm filters that you might not know about, and not just the Qualcomm filters, but the line conditioners using this technology, is that the more reactive your stereo is, which means I would call it higher level, the more it will be sensitive to the decrease in dynamics that these units have. So if you have a very basic system and you put it on a line conditioner, you might not notice that the dynamics have decreased to that much degree. And I would say this is especially true for solid state amplifiers, so they are not as much drawback on the life of the sound. But when you have a really attuned good high level amplifier, then if you put them on Qualcomm filters, then it just sucks out the dynamics and the liveliness. So it becomes a instant studio recording, like with added compression. So you can take it's like taking a live recording and making a studio recording out of it. That's what the Qualcomm filter will do to you. So what I do with my power amps, I will show it at a different episode. So now let's just go at the ratings here. So you see the smallest one in this list is 6 amps, and then we have 10, 20 and 60 amperes. I would recommend everyone to get the 60 ampere version, because that will have the least impact on dynamics. But when you look at the prices, you will just take a very sharp breath, because it will turn out that the 6 amp version is about $30, the 10 amp version is $34, 20 amp version, $82, and the 60 amp version, $120. So if you are wondering why on earth the line conditioners cost so much money nowadays, well, I think you got your answer, you got your question answered, because usually in audio settings this is what they use, the 20 amp version. If you go lower than that, you will find it in units which are advertised for line amplifiers, which is preamps and phonostages and DACs only. They will have the cheaper version, which is around $30. But if you want something for a power amp, they will advertise it as a power amp, 20 amp rated. It will cost an arm and a leg. But even in that case, I would not recommend these for power amps. If you have an evolved system. If you are at the beginning of your journey and you have a commercial solid state amp, then you probably will benefit from that scenario as well. And what can you do to create a higher amperage version of your filter? What I did do in my unit. So let's go back to the ceiling. So actually in this unit I have I think either 4 or 6 Qualcomm filters inside this unit. And what I'm doing is that here, this is my plugs, that's my AC inlet. I installed a dedicated line on the ceiling. That's a dedicated 20 amp line with wires running in the wall that can support 25 amps. And you see that's where the power conditioner gets the power. And inside it has 2 circuits. So one of the circuits is feeding the projector, and it has I think that one has 2 Qualcomm filters in it, and these filters are in parallel. So basically, as the current is coming in, it goes through both of them at the same time, and 2 times 20, so I have 40 amps current carrying capability for the projector. So that's double of what the products that give you that are rated for power amplifiers. And I have a second one, and there I have another pack of a pair of these 20 amp Qualcomm filters. So that's another 40 amps capacity feeding the Blu-ray player. And actually it's totally hardwired. There are no switches or anything inside, but later on I had to rewire the power switch so that power switch does work, because that's on the circuit that feeds the Blu-ray. So the other circuit that feeds the projector is on at all times. And why did I put the Blu-ray on a switch? That's because when I watch Netflix, sometimes it freezes up so badly that even though you try to turn it on and off manually or with the remote, it doesn't do anything. It's locked up, and the only way for it is to unplug it from the wall. And instead of, I got really tired of unplugging it constantly, so I installed installed back the power button for the circuit of the Blu-ray. And with this power conditioning, the picture quality is tremendously better. So basically I have a basic Epson projector. This is like a 2-year-old model. I got it pretty cheap, so this is today under $1,000 model, and it's only 2K. But because of the extra power conditioning and look, the power cords that I have on these guys, for the projector I'm running something really short. It's I think less than 15 inches long power cord, and it's a Kimber PK10, and I have removed the outer sleeve from it. So those are the inner wires of a Kimber. And I took out the black wire and I'm using the green one instead. So for me the green is not the ground, but please do not do it for yourself. If you don't know what you are doing, do not confuse people like that. But this is how I did it, white and green instead of white and black. Why, I will tell later on. But here, for the sake of this video, is that I'm running a bared and very short power cord, and the power cord to the Blu-ray player, that was that really junk lamp cord that they give for the Blu-ray, that really tiny thing, and I just totally ditched that and hardwired the Kimber PK10 into the motherboard of the Blu-ray, and that's a less than 8-inch long piece of wire running directly to the power conditioner. And why I mounted this on the ceiling, that's another story. But with this power conditioning scheme, this simple 2K projector has a picture quality that people, when they see it, they think this must be 4K, because it looks much sharper, much brighter. And if you have friends or know people who are disbelievers of power conditioning, this is really not a question of belief, and it's just insecurity that people do not trust their hearing. They just trust numbers that they can read, that a calculator or computer spews out, which you cannot trust anyway, because, well, I will tell you a story about statistics later on, how these numbers can be, actually the numbers are objective, but the interpretation, how you interpret those numbers, are pretty darn subjective, and unfortunately they are used today for sales pitch. And if you are one of those people who believe in your intellect, then my advice is to broaden your spectrum and learn, because that part that everyone, I would say not everyone, but where most people is stuck about when analyzing whether you can hear that, whether you can see that, it comes from scenarios where you don't know half of the variables. And when you know the rest of the variables, then even the measurements will make sense, but that small subfraction of measurements that you are receiving will tell you nothing. But even for these friends, when you put your projector on a power conditioner, then the change is very clearly visible. So thank you everyone for tuning in, and I hope now you have learned a little bit about the archetypal power conditioner, and also about the way how you can build it for yourself if you want, or how you can modify it. And we'll continue. Thank you. Please like, subscribe, tell your friends, condition your power. And this was just the first episode. Bye bye.